Hello students, in this video, we are going to discuss about methods of expressing the concentration. So what is concentration? Students, in general, what is concentration? Number of moles present in a given amount of solvent or solution or given liter of solvent or solution is called as concentration. So this concentration, students, can be expressed in so many ways by taking so many parameters like 100 grams of salt. How many grams of solute present in 100 grams of solvent? How many grams of solute present in 1000 grams of solvent? How many grams of solute present in 1 liter of solution, or in ml? So, or number of moles present in liter of solution. So there are so many ways to express this concentration, to find this concentration. So to start with, mass percentage. So what is mass percentage, students? The amount of solute present in 100 grams of solution is called as mass percentage. It's a percentage calculation saying about how much amount of solute present in 100 grams of the solution. So what is solution? Solute plus solvent together forms the solution. So students, what is the formula? Mass percentage equal to mass of solute by mass of solution into 100. This is the formula. Mass of solutions, remember, mass of solute plus solvent together will get the mass of solution. So this fraction is called as mass fraction. So mass percentage equal to mass fraction into 100. This is the other form of the same formula. So for example, 10% of the solution of sugar, which means 10% of the solution. What does it mean, students? 10 grams of sugar is present in 100 grams of the solution. That means 10 grams of sugar present in 90 grams of water. Yes or no? Why? Because 10 plus 90 together, solute is sugar, solvent is water. 10 plus 90 grams of water, which makes 100 grams of solution. That's what the point about the solution, students. So next, volume percentage. The same expression, if you want to express in terms of volume. Volume means you already know the space occupied is volume. Generally expressed in decimeter cube or liters or ml. That is a volume expression. So it is defined as the volume of solute present in 100 ml of a solution. So that is volume expression, volume percentage. So volume of solute by volume of solution into 100. Next, mass by volume percentage. First one is mass percentage, second one is volume percentage, third one is mass by volume percent. That means here the solute is expressed in mass and the solvent, the solution is expressed in terms of volume. So it is defined as the amount of solute in grams present in 100 ml of the solution. The same expression into 100 is mass by volume percent. The mass by volume percent is very, very important, students. During the medicinal pharma industry, mostly they use mass by volume only. So for example, so calculate the masses of cane sugar and water required to prepare 250 grams of 25% of cane sugar solution. So what is given here, students? What is given here? Already, but the percentage is given, right? What is the formula? Look at the formula. Mass by volume percentage equal to mass of solute by volume of solution into 100. Mass percentage equal to mass of solute by mass of solution. Mass of solution into, this is the formula. So what is the percentage? Already percentage is given, which is 25% equal to, we need to find the mass of solute, mass of cane sugar and water. Of course we can find that. So mass of cane sugar divided by, what is the mass of solution? To which solution, how much solution we need to synthesize? Which is 250 grams into 100. This is the expression, students. So here, to find this mass of cane sugar, so we have to rearrange mass of cane sugar equal to, so what do we get, students? 25 into 250 by 100, right? 25 into 250 by 100. 0 will be cancelled out. 25 into 25, how much? 625 by 10, which is 62.5 grams. That's it. 62.5 grams is the mass of cane sugar. But once read the question, we need to synthesize mass of cane sugar as well as the mass of water also. Cane sugar plus water together form solution or not? Now you already know mass of cane sugar. Now how can you find the mass of water? Simple. From the mass of solution is 250. Mass of solution is 250, students, and cane sugar mass is how much? Which is 62 0.5 grams. So now subtract, then we'll get mass of water or not. How much we'll get? Right, 187.5 grams we'll get the mass of water. That's it. This is mass percentage numerical, students. Percentage is given. We can synthesize solute as well as solvent also. Right, next. So strength of the solution, of course it is also like the mass by volume only, but here volume is expressed in the previous volume is expressed in terms of solution into 100, right, in 100 ml of solution, but here the volume is expressed in liter, students, in 1 liter of solution. That's what I said. Concentration expressions are different, depends upon the different parameters we are taking. So it is defined as the amount of solute in grams present in 1 liter of the solution. So this is the formula in liter. If you want to convert from liters to ml, so how much? 1 liter equal to how much? 1000. So into 1000, and these are the units, students. Mass is generally expressed weight by volume. That means mass is expressed in grams and volume in liters, right? So grams per liter inverse or gram per liter are the units of strength of the solution. Calculate the strength of the solution found when 4 grams of sodium hydroxide dissolved in 500 ml of water. So students, how much is the solute? How many grams? 4 grams. Next, how much is the volume of the solution? 500 ml. If ml is taken, you have to multiply with 1000, since 1 ml 1 liter equal to 1000 ml. So directly 2 times and 4 into 2, which is 8 gram per liter inverse, students. Right, they got the clarity. So that's how we can find the strength of the solution: mass, percentage, volume, as well as the strength. Mass by volume is almost close. Mass by volume is like 100 ml of the solution, but in strength is like 1 liter. Next, students, next we have parts per million. So when do we use this parts per million? Parts per million, that means first when the quantity of the solute is very minute, if it is present in the trace quantities, then we use this ppm. In shortcut we can also say ppm. When the solute is present in the trace quantities means very less quantities, then we use this ppm. It is convenient to express the concentration in terms of parts per million. It is defined as the quantity of the solute in grams present in 10 to the power of 6 million grams of the solution. So look at the formula: ppm equal to mass of solute by mass of solution into 10 to the power of 6. Why we are multiplying with that such big number? Why? Because the solute concentration is very less. To make it big, so we have to multiply with this 10 to the power of 6, which is a million. So for which type of entities we express this ppm. So atmospheric pollution in cities is also expressed in ppm by volume. It refers to the volume of pollutant in 10 to the power of 6 units of volume. Atmospheric pollution, carbon dioxide. What is the carbon dioxide percentage in the atmosphere? Almost like 0.02%, right? So the increase in the percentage pollution of CO2, if you want to express it, it is convenient to express in ppm. Why? Because it is a very small quantity when comparatively with the atmosphere, the remaining gases. For example, 10 ppm of SO2 in air, which means 10 ml of SO2 is present in 10 to the power of 6 ml of air. Got the clarity? So solvent is a very big quantity, then it is convenient to use in ppm. Why? Because we are multiplying with such a big number. Next, molarity. Students, molarity is very important. Concentration expression. What is molarity? It is defined as the number of moles of solute per liter of the solution, or in ml also we can express. We have a conversion factor. So very important. Molarity is widely used. It is defined as the number of moles of solute per liter or per dm cube, decimeter cube also of the solution. Molarity equal to number of moles of solute by volume of solution. Direct simple formula: number of moles of solute by volume of solution in liter. If you want to convert into ml, what we have to do? 1000, right? Next, how to calculate this number of moles, students? Number of moles can be calculated by taking given mass by molecular mass. So number of moles of substance can be calculated by, so look at the formula: weight of the substance by molecular weight of the substance. What is weight of the substance? Weight of the substance is the given mass. It can be anything like 10 grams or 0.2 grams or anything, 100 grams. But what is molecular weight? Molecular weight is fixed. For example, hydrogen gas. What is the molecular weight? 2 grams. Carbon dioxide, what is the molecular weight? 44 grams. Oxygen gas, what is the molecular weight? 32 grams. Got the clarity? That is fixed. So given weight by molecular weight, we'll get the number of moles. So here, for example, number of moles present in 3.65 grams of HCl. Number of moles equal to weight of HCl by molecular weight of HCl. What's the weight of HCl, students? 3.65. That is a given. But what is the molecular weight of HCl? 36.5. Molecular atomic mass of hydrogen is 1, chlorine is 35.5. So 1 plus 35.5, which is 36.5. So in this mass, how many moles are there means? 0.1 moles. So that's how we can calculate the number of moles. So molarity is also given by this formula, like rearranged for molarity equal to, so look at this expression, number of moles we can simplify as weight of the solute by molecular weight of the solute into 1 by volume in liters. If it is ml, we have to convert into ml, like which is 1000. So 1000 by volume in ml. So for example, we have a numerical here. Calculate the molarity of 200 ml of a solution formed when 4 grams of caustic soda is dissolved in water. What is caustic soda formula, students? Caustic soda is NaOH. Caustic potash is KOH. So here first of all, we need to find the number of moles. Number of moles. How many? What is the given mass? 4 grams, right? 4 grams. What is the molecular mass? To find the molecular mass, you should know the formula of caustic soda, which is NaOH, is the sodium hydroxide. So what is sodium? Sodium mass is 23 grams, oxygen 16, hydrogen is 1. 23 plus 16 plus 1. How much, students? 40 grams, which is 0.1 moles. Okay. According to the formula, what is the formula of molarity? Number of moles by volume. So here we got 0.1 moles into. And what is the volume factor? Given in ml. If a volume is given in ml, students, if volume is given in ml, we have to multiply with 1000, right? 1000 by 200. That's it. This expression. Zeros will be cancelled out. How many times? 5 times. So 0.1 into 5, which is how much? 0.5 molar. Capital M. The units will be capital M. What is the meaning of molar? Number of moles per liter. So what is the answer here? 0.5 molar. That means there are 0.5 moles of caustic soda present in 1 liter of the solution. Got the clarity about molarity? Next we have dilution law of molarity. Simple. Dilution law is nothing but there is one solution. You added some water. Now the molarity of the solution changes or not? Like you added some solvent. So that's what we have, some initial values, and we also have some final values. So for this expression we have like initial and final values. If initial molarity is M1 and initial volume is V1, if we change V1 to V2, then M1 changes to M2, and this is the expression. Before dilution M1 V1, after dilution M2 V2. M1 V1 equal to M2 V2. If you know any of the 3 variables, the 4th one we can find out by this expression. So this is the dilution law. Next, molality. Molality is one more way of expressing the concentration. In molarity we expressed solution in liters, sir, but here in molality we express the denominator in terms of solvent in kg, kilograms. Their solution liters, here solvent in kg. That is the difference between molarity and molality. It is defined as the number of moles of solute present in 1 kg of solvent or 1000 grams of the solvent. The same expression, how to find the number of moles? Weight of the solute by molecular weight of the solute divided by weight of the solvent in kg. If it is in grams, students, you have to multiply with 1000 by weight of the solvent in grams. So for example, let W be the gram of the solute of the molecular mass MB. This is the gram of the solute, molecular mass is MB. Now the whole expression indicates number of moles of solute divided by mass of solvent. Yes or no? Into 1000. Why into 1000? In grams. If you want to express in grams, into 1000. So units of molarity, moles per kg, or it is indicated by small m. Molality is the most convenient method to express the concentration because it involves the mass of liquids rather than their volume. Correct. Why? Because students, volume factor always changes. It's a temperature dependent. Temperature changes, volume changes, but molality is temperature independent. That's why if you increase the temperature, does the mass changes? No, the mass always remains same. That's why it's the most convenient method to express all these concentrations, students. Next we have a numerical of molality. So what is the numerical? 214.2 grams of sugar syrup contains 34.2 grams of sugar. Calculate the molality of the solution. Molality small m equal to, what is the expression, students? Number of moles of solute divided by mass of solvent, right? So of course grams given into 1000. That's it. Got the clarity, students? So how to find the number of moles of solute? Number of moles we can find by mass of the solute by gram molecular mass. Okay, right? Now here first of all, sugar syrup. Which is solute, which is solvent? sugar syrup is a solution. It contains sugar and water. But how can we take the mass of solvent? It's simple. 214.2 grams of sugar syrup contains, students. It contains 34.2 grams of sugar. Yes or no? The solution minus the solution mass minus solute mass. What will get? Solvent mass or not? Yes or no? So 214.2 grams minus, which is 34.2. So how much, students? 180. 180 grams. 180 grams is the mass of the solvent. So we got the mass of the solvent, okay? And what do we need to find? We need to find the number of moles of solid. How to find the number of moles of solid? You already know the mass of solid. How much? 34.2 grams is the mass of the solute. And 34.2 grams is the mass of solute. And what is its molecular mass? What is sugar, students? Sucrose, C12H22O11. So it is 342 grams is the mass of the molecular mass of the solute, and the given mass is 34.2 into, and how much we got solvent? 180, means 1000 by 180. So 34.2 by 342, which is 0.1 into 0 cancel. 100 by 18, how much, students? 18, 5 times, which is 90.0, again 5. So 5.55 will get. So 0.1 into 5.55, which is 0.555 small m, molal. This is the molal expression. So what is the answer? 0.555 molal. For molarity you have to say molar. For molality you have to say molal. So what is molal expression? Number of moles present in kg of solvent. 1 kg of solvent is molar expression. So these are all the concentration expressions, students. So what we discussed in this video: mass percentage, volume percentage, mass by volume, strength of the solution which is expressed in liters, as well as molarity and molality. So these are the few concentration terms. We have other also concentration terms also, like normality, formality, that we'll discuss in the next video. Thank you, students.